An AA battery. A small, everyday object we use so often that we rarely think twice about it. TV remotes, wall clocks, kids' toys. When the battery dies we replace it and the old one ends up in a drawer, or in the trash. But an AA battery is more than just a power source. Inside it's carefully built from different materials, each with a specific purpose. And one of the most interesting parts is the carbon core. This carbon core is designed to conduct electricity, withstand heat, and remain stable under harsh conditions throughout the battery's life. It doesn't burn easily, it doesn't deform quickly, and it transfers heat fairly evenly, qualities that might sound familiar if you've ever thought about how another tool works. A soldering tip. At its core, a soldering tip needs just a few things: high heat resistance, stable heat transfer, and enough rigidity for precise work. And surprisingly, the carbon core from an AA battery meets these requirements quite well, at least for low-power, basic soldering tasks. That's why turning an AA battery's carbon core into a homemade soldering tip isn't a random experiment. It's actually a reasonable material choice as long as you understand its limitations and use it correctly. And that's exactly what we'll do in today's video. Nothing fancy, nothing expensive. Just taking a discarded AA battery, reworking its carbon core, and turning it into a simple DIY soldering tip for practical use. So if you're curious how something usually thrown away can become a useful tool, let's get started. So, the DIY soldering tip made from an AA battery's carbon core is now finished. It may look simple, but it actually seems pretty reliable, doesn't it? And for this project I'll take it a step further. By making a second soldering tip, turning this into a dual-tip soldering tool. Next, I prepare a complete bolt with 2 nuts. The bolt is about 10 centimeters long, perfect for forming the handle and soldering head, connecting the DIY tips into a unique structure you don't usually see on YouTube. After securing the soldering tip with 1 nut, I install the second nut to clamp and connect the wire to the soldering head, making the whole assembly more solid. This is a single core wire made up of many thin strands twisted together. I use this type of wire quite often in my DIY projects, especially when working on compact, homemade soldering tools. The reason is simple: it's flexible, easy to bend, and the strands don't break easily with repeated movement. More importantly, it provides stable electrical contact. When clamped with a nut or tightened onto the soldering head, the braided strands increase the contact area, reduce resistance, and help prevent localized overheating. For low-power DIY soldering tools, this kind of wire strikes a good balance. Durable enough, flexible enough, and easy to find. It's one of those materials that just works well for small, practical builds like this. One end of this wire has already been securely connected to the soldering head. I'm not in a rush to deal with the other end just yet. Instead, I temporarily secure part of the wire along the handle using electrical tape. This keeps the wire from moving around and, more importantly, makes the tool much easier to handle while testing how effective it actually is. During testing, keeping everything neat and stable comes first. The rest can wait. For the other end of the wire, I'll attach an alligator clip, making power connections quicker and more flexible. This is the alligator clip I mentioned earlier. It's a small accessory, but incredibly useful for DIY projects, especially when you need quick, secure, and flexible power connections. Actually, we're not done yet. This alligator clip is only used to connect to the positive terminal of the power source. To complete the setup, we need to make one more tool. The structure is simple: a piece of wire with an alligator clip on each end. This cable will be used to connect to the negative terminal of the power source, completing the circuit and allowing the device to operate properly. This small battery pack will provide all the power we need for this project. Even though it's compact, it can still deliver a stable and sufficient current for a low-power homemade soldering tool like this one. One big advantage of using a battery is its relatively steady output. It doesn't drop voltage too quickly when the load changes, which is especially important during testing. A stable power source helps keep the soldering tip temperature consistent, making it easier to judge how effective the setup really is. And to accurately evaluate how effective this homemade soldering tool really is, I'll run a few small tests. We'll see whether it can join small metal parts together cleanly, and more importantly, whether it can do that without damaging the materials in the process. Real-world results matter most. So if you're curious to see how this DIY soldering tool performs, make sure to watch until the end of the video. I hope you'll understand and bear with me. I've muted this part because the surroundings were quite noisy and could affect your viewing experience. And as you can see, all the small tests were successful. This homemade soldering tool works steadily, the joints are strong enough, and most importantly, it does exactly what we expected it to do. Starting from a few very simple materials, even items that would normally be thrown away, with a bit of understanding and experimentation, we can still create a genuinely useful tool. DIY doesn't always require expensive equipment. Sometimes all it takes is a good idea and a little patience. Thanks for watching until the end, and I'll see you in the next project.